Okay, so I'm going to record a video about finding the constant of proportionality or the unit rate. So this is an example that I created the x and y table. For instance, x in this example stands for the number of cups of water and the y stands for the number of drops of food coloring. So I see that the pair of 0 and 0, which is the origin, is part of this table. So this is probably a proportional relationship, but I can't tell unless I solve it. So when I look at here, I have 11 and 99. So that is 11 being multiplied by 9 to get 99. So I'm going to go ahead and multiply by 9 for each of these. So here I'll get 45 times 9, here I'll get 18. And if I had 18 and I wanted to find the 2, so I would divide by 9. So if I was going backwards, I would divide by 9. 1 times 9 is 9. So that means for each cup of water, I use 9 drops of food coloring. So that's my unit rate. This is my unit rate. In 6th grade, we used to call that unit rate. In 7th grade, we call that the constant of proportionality. So if I have X number of cups of water, I'm going to multiply that by 9 and I will get 9x. So this is going to help me write my equation because 9x is equal to y. So my constant of proportionality in this example is 9 drops of food coloring for each cup of water, and my equation, remember that equation for a proportional relationship, it looks like y equals k times x, and k is the constant of proportionality, which we found here, it's 9. So I'm going to write my equation, y equals 9x. So that's my equation for this table. Now I have another table here that kind of looks similar. It doesn't say what x and y stand for, so it could be cups of water, drops of lemon juice, or really anything. I see the 0, 0, so that gives me an idea that this might be a proportional relationship. The row that I can start is going to be this row. I see that 3 times 2 is 6, but I'm supposed to be getting from the x column to the y column. So one way I can solve this, I can say that 6 is divided by 2. So 6 divided by 2 is 3. But I can't use the 2 here because it has to be multiplied by a number, not divided by a number. So I know that dividing by 2 is the same thing as multiplying by 1/2, because 6 times 1/2 means 1/2 of 6. So that's going to give me 3. It's still giving me the same answer. So this is multiplied by 1/2. Of course, I can use the decimal. I can use 0.5 because 1/2 is 0.5. So I can use decimal if I wanted to. If I wanted to use calculator, I probably should be going with the decimal form of this. So if I multiply this by 1/2, that's 1/2 of 4, so that's equal to 2. 1/2 of 5, which is 2.5. Here I have 4.5, so if you look at this one, if you were to go backwards, you have to multiply 3 by 2 to get 6. So I have to multiply 4.5 by 2, which gives me 9. I left this one blank because I wanted to find the value for 1, because the only thing that will give us the constant of proportionality is when we have the x value equal to 1, because that's going to give me the unit rate. Remember, unit rate is used in 6th grade, and in 7th grade we use constant of proportionality, which is the same thing as unit rate. So when I look at here, I see that I multiply each of these values by 1/2 to get to the next one. So I will do that here, and it's going to give me 1/2 or 0.5. When I have the x, then I will multiply that by 1/2 also, and that's going to give me 1/2 x, or I can say 0.5 x. So my constant of proportionality is 1/2 or 0.5, and I can write my equation y equals 1/2 times x. That means any y value that I want to find, any number here that I want to find, I can go ahead and multiply by 1/2 for the x of that row. So if I have 9 and I multiply 1/2 times 9, it will give me 4.5. If I have, for instance, 6, I multiply that by 1/2, it will give me the y value. So I can basically use this equation to plug in any x that I want to find the y value, and vice versa. So I've got another problem that looks like this. So also very similar to the previous one. It looks like if I take the 2 and I multiply it by 3, it's going to give me 6. But I need to find what multiplies by 6 that is equal to 2. So another way you can find it, which always works, is that you can find by constant of proportionality. You can find it by dividing y by x. So it is always y divided by x. It's not necessarily the bigger number divided by smaller number. It is always the value of y divided by x. So in this case, my y value is 2 and my x value is 6. So I have to be doing 2 divided by 6, which if I put in calculator, it's going to give me 2 divided by 6. It's going to give me a decimal that is a non-terminating decimal, so I can't really use it. So I will go ahead and stick with fractions. I'm going to say 2 divided by 6, and I'm going to simplify this fraction. Another word for it is reduce the fraction. So this is going to give me 1/3. So that looks like if I multiply this by 1/3, so 6 times 1/3, I can put a 1 here, I can multiply across and get 6/3, which is 2. So 6 times 1/3 is 2. So basically I have to go ahead and multiply by 1/3. So 18 times 1/3, I can do it here, 18 times 1/3, just like this one. It's going to give me 18/3, which is equal to 6. So if you look at the pattern, if you take this number and multiply by 3, you will get this number. So I can solve it that way too. If I have this number, so for instance 2 times 3 gave me 6, so I have to multiply this by 3, which gives me 90. But if I have the x value, I have to multiply it by 1/3. Now multiplying by 1/3 is the same thing as divide by 3. So basically divide by 3. So I can put this in the calculator, 135 divided by 3, and that gives me 45. I can also check it by doing 45 times 3, which is going to give me 135. So far everything is going well. I have to find the value of y, value of x being 1, because that will give me the unit rate, or constant of proportionality. So if I go ahead and divide 1 by 3, I'm not going to use my calculator, because again it's going to give me 1 divided by 3, so it's going to give me a non-terminating decimal. This is really not helpful, so I'm going to go ahead and write it as fraction, 1/3. That means 1 divided by 3. So for the variable here, m times 1/3 is 1/3 m. So sometimes instead of x and y, they use different letters, and that's totally fine. This is really our x and this is really our y, and our equation is going to be y equals k times x Remember, K is our unit rate, it's our constant of proportionality, which is 1/3 here, which we found it. Instead of X and Y, they want me to use M and N. So instead of X, they want me to use M, so I will use M here. My constant of proportionality is 1/3. And instead of Y, they want me to use N, so I will replace N here. So this is my equation for this proportional table. So one last one is looking into this one. So instead of X and Y, they are using A and B. So I have to take the Y value and divide it by X. So that's 10 divided by 8. Now there is a way to figure this out without even a calculator. I can simplify, and that gives me 5/4. 5/4, that means how many groups of 4 are in 5? That's one group of 4, and 1/4 is extra. So this is really equal to 1.25 because 1/4 is a quarter. So that's like having 25 cents, so 1.25. So I can use either 5/4 or I can use 1.25. If I'm going this way, I'm going to multiply by 5/4, so 5/4 or 1.25, and this is giving me the unit rate. This row by itself is my unit rate or the constant of proportionality right here, which is 5/4. So 8 is already done, so I can check it times 5/4. So if I do 8 times 5/4, I'll do that here. So 8 times 5/4, I can put 1 here, I can multiply across and get 40/4. 40/4 is equal to 10. So we already had the 10 and we were just checking. So 20 times 5/4, so I'm going to do that here. 20 times 5/4. So again, put a 1 here, multiply across, that's 100/4. 4 goes into 125 times. So that's 25 right here. Now, if I have the Y value and I need to go backwards, I'm not going to multiply by 5/4, I'm going to divide by 5/4. Or I can divide by 1.25 and use my calculator. So I can either do 30 divided by 5/4 and work with fractions, in which case I need to know how to divide fractions. Or I can do 30 divided by 1.25 and go ahead and use my calculator. So that's giving me 24. If I solve this correctly and simplify, it will also give me 24. So 24 here, and one more, in this case times 5/4. So 32 times 5/4. Again, instead of 5/4, I can use 1.25. So I'm going back and forth between fractions and decimal. So then you know that basically it's doable both ways. 32 times 1.25, and that gives me 40. I could have also solved it a different way. I could have said 8 times 4 is 32. So I can take the 10 and multiply by 4. So basically I can use the side connections if they work. Like I can't use the 20 to 32. It's not as straightforward. I can, but it's not as straightforward. But I can use 8 to 32. Or here I can say, use a different color. So 10 times 3. It's not a different color, it's a pencil. So 10 times 3 is 30. So I can do 8 times 3 and get 24. So that might have been even easier. So A times 5/4, 5/4A, or 1.25A, and that value is equal to B. So they don't want you to use X and Y, they are using A and B. So 5/4A equals B. Or if you're going to go with fractions, or you're going to go with decimal, or you can write both of them. So this is 4 examples of tables that show proportional relationships, and we can use the connections going across from x to y, or we can use connections from the side if they work, and we can solve it that way. Remember that to find the value of the constant of proportionality or unit rate, you always do y over x, y divide by x. It is not necessarily bigger number divide by smaller number, in which we saw here that we were doing 2 divide by 6, which we can write as a fraction, and then we can just simplify the fraction. Once we find this number, we can use that to write the equation. This number goes into the equation right here. So it becomes, for instance, here it became 1/3. So y equals 1/3 x. They were just using different letters. In this case, b equals 1.25 a, and we had the previous examples the same way. This is the equation of a proportional relationship, and this is the way we find the unit rate or the constant of proportionality in any proportional relationship.